up. So I'm doing a PhD in immunology. So immunology, what does that mean? It means I am after your blood. In a single drop of your blood, you've got about 4 million red blood cells, and they're racing around your body carrying oxygen. You need them to breathe, and you can keep them because they're dull. I'm not interested in your red blood cells. I want the 5,000 to 10,000 white blood cells from that drop of blood. They are the superheroes of your immune system. They keep you fighting fit. They help fight off infections and even cancer. I bloody love white blood cells. And I'm not alone. I have just come back from the climax of the Immunologist's Year, the British Society for Immunology Congress. It's a 4-day nerd party for white blood cell lovers. It's great, except rather than just staying up all night drinking, you also stay up all night for 2 weeks beforehand frantically making PowerPoint slides, because it's a nerd party. So for this conference, I had to make a poster. It's a pretty common way for scientists to communicate their research to each other. You get a big sheet of A0 paper, you put some graphs on it, you give it a title, you write some little descriptions of the graphs, and then you stand next to it for 2 hours clutching a glass of wine while people avoid making eye contact with you. So I really wanted to nail this poster. I wanted it to be great. So I decided to turn to someone who's got a lot of experience and wisdom, someone I really trusted for advice. I Googled it. And Google gave me some interesting advice. So Google said that I should model my poster on a magazine cover to make it more enticing. That's not bad advice, but the magazine that this website chose was Cosmo. So I had this vision of a pink poster with 10 ways to keep your cells happy and interested. Hot new lab coat trends for spring. Another one of my favourite tips was to get a picture of your poster and get it printed on a t-shirt so you could be the best dressed at the nerd party. I didn't follow this advice. In fact, I didn't have a great start to the conference because once I'd done my poster and sent it off for printing, went to the photographics unit to pick it up, to find that John the cleaner had put my poster in the bin by accident. Well, accident, I think it maybe speaks to the quality of the poster. But it was fine, they printed me another one, and I got on a train to Liverpool to go and speak to another 1,600 people about white blood cells for 4 days. So why would that many people care about white blood cells? They are the superheroes of your body. I like to think of them as the Avengers. They've all got their own special superpowers to help you fight off infections and cancer. But like the Avengers, they can also be kind of meatheads. They sometimes get confused about who the real bad guys are, and they'll go after innocent bystanders, and that's when you get problems like allergies. And they also, when they get into fights, cause a hell of a lot of collateral damage. When you get the flu, that horrible, feverish, shivery feeling, that's not technically the virus doing that. It's your immune system hulking out and throwing cars and knocking down buildings. And if your immune cells are the Avengers, I like to think of myself as Nick Fury. Trying to understand, maybe manipulate them, and sometimes just having to stand back and wonder what the hell they are doing. We don't really know why your immune system goes wrong when it does, but the 3 years of a PhD aren't exactly long enough to answer all of the mysteries of your immune system, or at least this is what I keep trying to tell my supervisor. So I had to pick just one topic, one type of cell. So I work on natural killer cells. So, natural killer cells, they are actually called that. So natural killer cells were first seen in 1975, so they're pretty young and hip, by a PhD student called Rolf Kiesman. And he noticed that these cells were able to kill cancer cells, naturally. Immunologists are not the most imaginative when it comes to naming things. Fruit fly guys have loads of fun. They named a fruit fly mutant Lush because it's very sensitive to alcohol. We found a really important cell in the bone marrow, so we called it a B cell. Mouse researchers, they've got more poetic souls. They named a mouse mutant Stargazing because it looks up a lot. We found a really important receptor on the B cell, so we called it the B cell receptor. And then our immense creativity ran out and we just started numbering things. CD1 to CD371. If that's not enough to put you off immunology, I don't know what is. But it didn't put off Rolf Kiesman. When he first saw natural killer cells, you might think that he shouted Eureka. I'm pretty sure he shouted bollocks. Because he was a PhD student, and he was actually trying to figure out how a different kind of white blood cell, a T cell, kills cancer. But, like many PhD students, his experiments were not working. He was getting a lot of background killing. And after what if anything in your experiments doesn't work, you just call it background. But after a lot of swearing and a lot of repeats, he thought, actually, maybe I've just found a new kind of cell that can kill cancer. Naturally. So he wrote off to the European Journal of Immunology and got his paper published on natural killer cells and set the ball rolling on a whole new field of research. He's either my hero or the architect of my doom. So what do I do with natural killer cells? They are the assassins of your immune system, the Black Widows in our Avengers. They dispose of cancer cells and virus-infected cells quickly and efficiently. But they don't do it alone, they need to talk to other cells, and I'm interested in how they communicate with the other cells. I can't study them in a living, actual human because there are ethical issues with giving someone a disease just to do experiments on them. So I get blood donations, and we take donor blood and we use magnets to pull out the cells we want, like real superheroes. And then we treat them with chemicals to make them think there's a disease around, and then I get to fire lasers at them. So we put different dyes on them to put them under a microscope, and we fire lasers at them and make them glow different colours. And I spend 5 hours sitting in a dark room trying to figure out what those colours actually mean. So between the lack of sunlight and the constant collection of blood, I think my PhD may be turning me into a vampire. But beside the undead problem, I have another issue. If you look around the room, you'll see that humans are wonderfully diverse. And I don't know anything about my blood donors. They could be 28 or 82, large or skinny. They might even have allergies, and all of that can change the way that their white blood cells behave. So when I get my natural killer cells into an experiment, sometimes I get my ruthless assassins, my black widows, killing efficiently. And sometimes I get confused house spiders running around in circles. The experiments don't always work, which is maybe why my poster ended up getting thrown in the bin. After 2.5 years of careful research and experiments and planning, I've made my big discovery, though, that I probably should have picked an easier field of research. But I wouldn't change a thing. I bloody love white blood cells. They are the superheroes of your immune system. And plus, immunologists throw a wicked nerd party. Thank you.